Algebra 2, 22. So the idea is this. When things are moving at the same speed for long periods of time, we can simplify it down to the following equation. Distance equals rate times time. Okay, this should not come as a surprise to you. If the speed limit is 50 miles per hour and you are traveling 50 miles per hour for 1 hour, how far did you go?
50 miles.
50 miles. Why? Because 50 times 1 is 50. If you travel 50 miles per hour for 2 hours, how far did you travel?
100.
100. Why? Because 50 times 2 is 100. Right? Surprised? Anybody? No. Now, in these problems that you're going to have, you are going to have a specific, so this is your distance equation. So on your formulas sheet, that is the actual one I want you to give. Distance equals rate times time. And then, you okay? Okay. We are going to have either two people travel the same distance or someone's going to travel somewhere and then come back. So suppose you're here in this classroom. We'll draw our school as a box because it's pretty boxy. It's got like a little courtyard and the palm tree, right? And it's like, ooh, palm tree. Okay, anyways, we're here. So suppose you, I don't know, walk to CVS. CVS is a bigger box. It also includes the words or the letters C, V, and S on it. And you go there and then you come back, right? What do you know about the distances if you go somewhere and then you come back? They are the
exact
same. So the distance there, or D1, is the same as distance 2. What is distance? Distance is
Rate times time.
rate times time. Everyone tracking with me?
Yes.
Distance is rate times time. If you go somewhere and come back, it's the same distance. So D1 can be written as R1 T1. The rate of you going times the time of you going. And that equals the rate of you coming back times the time of you coming back. And this is the equation that is going to ruin your lives for the foreseeable future. Okay? So, when two distances are the same, then we can use this equation. Now, these are word problems, and we all know how we feel about word problems, right?
Yeah.
Love them, right? But later on, you guys are like, how does this apply to real life? And the word problems are the ones that actually apply to real life. So you're like, I hate these, but I love it. It's like the Bible, right? Like you love the principles. You love the idea of what's in the Bible, right? God's like, I don't like lying. And then when you're in a position to lie, you're like, I hate that. But I know it's the right thing to do, but I don't like it. Right? Like that's the war we have amongst ourselves. And it's like, that was our Devo this morning with the seniors. It was like that there's like two things that are desired, and it was like, I can't remember what it is now. All right, that's gone. Anyways, the point is, we have this equation. It's going to ruin our lives, but it's okay because we're going to learn how to use it properly, and then we're set. I will find the Devo eventually so that we can go through it. I think it's like Proverbs 30. So I'll just write that note here, and you guys can look it up later. Anyways, that's that. So here is our word problem. Are you ready? Are you ready? Nobody's ready. Are you ready? I will need verbal confirmation.
Yes. Affirmative.
That's not verbal.
C.
Okay. Verbal confirmation.
Affirmative.
Back table.
Yes. Engage. Yes.
Front.
We. Yes.
Okay. All right. Roger. We don't call teachers by their first. Mr. Cotton made the trip on Sunday, and Judy. We don't call non-teachers by their first name either. We'll call, who's Judy?
Grasimoff?
Grasimoff. There we go. Mrs. Grasimoff made the same trip on Monday. So it may help you to draw a picture. Okay? So we have Roger and we have Judy. Now, they made the exact same trip, different days. Okay? But it's the same trip. So Roger started here, ended here. Judy started here, ended here. What do we see from this picture? The distances are the same. So you want to be specific. The distance is the same. Why? Because if the distances are the same, then I can use this equation. Instead of 1 and 2, which might be hard to remember, I'm going to use RR, TR, and RJ, TJ. R stands for Roger. J stands for Judy. Okay? So, it says Roger traveled at 12 miles per hour. Now, which of these letters should I plug in 12 for? If Roger traveled at 12 miles per hour, is that a time?
No, that's rate.
No. Okay? If it's something that your like little speedometer would show you on your car, like miles per hour, kilometers per hour, meters per second, some like weird fraction, that's your rate. So I know that since Roger traveled at 12 miles per hour, they gave me that in the problem, I'm going to plug in 12 here. They also tell me that Judy traveled at 20 miles per hour. Where does 20 go? RJ. You're going to line everything up vertically. So I don't know TR, so I'm going to put TR. RJ is 20. TJ is someone's name as well, but it means time of Judy. Okay? Now, let's see what else they tell us. Her time was 2 hours less than Roger's time. So I have this equation, but I'm going to need one more to complete my mustache. Right? A one-sided mustache would look quite strange. Right? Like you have the Belanda and like the smile. Let's pretend he's smiling. And we know it's not always true. And then the whole nose thing, right? What if you had a one-sided mustache? Like that would look strange, right? You need the full experience of the Belandis and maybe even like the little like the thing and then probably hair. Although receding hairline because he's a teacher, so he kind of loses that like right there, the little widow's peak, right? But then you got like the little connection spot, and there's Belanda, right? But half a mustache, like that's not okay. So we have to write the other half of the equation. If Judy's time was 2 hours less than Roger's time, how would I write that? Here's how I want you to start. Assume that they're both equal to start. Then you're going to balance it accordingly. So if Roger's time equaled Judy's time, you would put that they're equal. But Judy made it in 2 hours less. So where do I subtract 2 from? I know that we're saying like Judy, 2 hours less. You might want to put it over here. But that would mean that Roger's time was Judy's time minus 2. So I'm actually going to subtract 2. I know you guys know it. I'm going to subtract 2 there. Why? Because Judy's time is 2 hours less than Roger's time. Remember when we do less than, we always put it after the thing. So 2 hours less than Roger's time would be minus 2 of Roger. Now, if you're not convinced, let's test it out. If Judy's time was 5, Roger's time, or if Roger's time was 5, Judy's time was 3. Does that work?
Yeah.
That's what we want. Now, if I put the minus 2 on the other side, I will get the opposite. Please don't die.
We'll say we all prefer the living.
Okay, you're good. Please cover your cough with your elbow, like so. It is like the early 2010s dance move. Okay, anyways, moving on. So, you guys missed that in the back row.
No,
One of you got it. All right, so now the mustache is complete. How do I solve this? Well, even though I don't like it, I'll probably use substitution because I already have TJ solved for, which is also the name of a sibling of somebody in this room. Moving on. So TJ is TR minus 2, so I have 12TR equals 20TR minus 2. Multiplying this out, 12TR equals 20TR minus 40. Make sure you distribute that. Then I'm going to subtract 20TR. And hopefully, if you get like a negative number, you know you did it wrong, right? Like, so don't even bother giving me that answer. Like, fix it. Don't just leave it as wrong and be like, oh yeah, they traveled for negative 8 hours. Like, that's not right. You know it's not right. I know it's not right. We all know it's not right. Like, fix it. Don't just sit there and be like, oh, cool, I'm done with my test. And then you're like, oh yeah, they traveled negative 8 hours. That doesn't make sense, okay? So if I divide by negative 8, I get TR equals 5 hours. Before, you had these problems where they were just letters, and they meant nothing. So you didn't have to put units. Now they mean something. They mean time. Therefore, you have to indicate the units. Okay? They want to know how far did they travel. Have I answered that question?
No.
No, I answered what Roger's time was. Okay, question?
I was gonna say, instead of like doing the two equations, would it be alright if you just plug?
No. You have to show your work. Sorry.
I know, but I'm gonna.
Just like plug this in.
Yeah, and then you could show your work that way. No.
No. I've skipped a few steps here. This is probably about the minimum amount of work that you could show.
Okay.
I'm sorry. Because a lot of people get this wrong when they don't think through this stuff, so I'm making you write it. Sorry. All right, so we found TR. What are they asking for?
The time. Wow.
They're not.
Distance. Wow.
They're asking for distance because they said how far did they travel. So really what you have to answer is, if I want to know the distance, I can choose either one of these. In this case, I know the time of Roger and the rate of Roger. So let's just plug them in. Rate of Roger is 12. Time of Roger is 5. What was the distance?
60.
60 what?
Miles.
Miles. Why? Because if we have miles per hour times hours, they cancel and we're left with miles.
There you go.
So that's your answer. Read these questions carefully to make sure that you have them correct. Now, the lesson is not over. Now we're going to talk about something completely different and use more time. So, let's do so. This lesson also has a little bit of similar triangles in here. So, how would I solve this similar triangle? I think we've seen this one before. So, and we have a bunch of numbers. Let's do 6, z, and 9, and y, x, and 5. Okay, my instruction to you was to first draw out the two triangles facing the same way and do similar triangles that way, right? That is still my instruction to you. So let's redraw this one. We'll keep that one the same. And we'll flip this one around so it points in the same direction. So 1 is there, 2 is there. So between 1 and 2 is x. Between 1 and unknown is 5. Between 2 and unknown is y. So you kind of flip it around, and then you can do similar triangles. So choose the two that you know the sides for, like 6 and 5. And then choose two that you don't know. So maybe a 6 over 5 equals 9 over y. If you cross multiply, you can solve for y.
What's new?
45 over
6.
Y.
So like divided by 3, that would be like 15 halves. No. Yeah, I'll buy that.
Yeah.
Okay, now what? Can we solve for z? That's a 7. Okay. Can we solve for x?
Yeah.
Yeah. What's new about that? I have no clue. So, that's it. So let us begin the lesson.